All we've covered today so far is the upper urinary tract. Now we've got to finish up with the anatomy of the lower urinary tract. That includes the ureters, which is the pathway for urine from the kidneys to the urinary bladder itself, and the urethra. Luckily, none of these is nearly as complicated as the nephron. So the ureters have 3 layers, very much like everything else you've seen: a mucosa, a muscularis, and an adventitia. What does that word adventitia mean now? Is it free or embedded? It's embedded, and part of it actually is free, part of it is actually embedded. So it's kind of a weird phrase for that. Honestly, I may be more inclined to call it a serosa, but whatever, go with it. Okay, ureters, and again, you do have a sort of muscularis along the midline, so it does have smooth muscle that's going to aid with contraction and moving urine from the renal pelvis to the urinary bladder. Even if you're standing on your head, it's still going to go one way. You really want that to be one way. When it's not one way, there's a problem. Those ureters bring urine to the urinary bladder, and that's going to store urine that has already been formed. It's immediately posterior to the pubic symphysis. For women, it'll be anterior to the vagina and inferior to the uterus, especially if that uterus is tilted forward. Different women will have different tilts to their uterus. Don't worry about that, though. And then in men, it's directly anterior to the rectum. Now, within the urinary bladder, it does have a detrusor muscle embedded within the wall of the urinary bladder, and that's going to cause contraction when it's time to urinate. The ureters are going to deliver urine down to the urethral opening at the trigone. The trigone is a triangular area of a slightly different type of epithelium. It's less rugose, less folded in a relaxed bladder. So urine is draining here, and then as it fills up, it will fill up in the superior direction. So again, 1, 2, 3, that's why we call it the trigone, from the 2 urethral openings to the urethra. And you do have an internal urethral orifice and an external urethral orifice. And that's pretty fortunate, very much like with the excretory system, very much like the GI tract, and its internal anal sphincter and external anal sphincter. The internal urethral orifice has a sphincter around it that is smooth muscle and under autonomic innervation, whereas the external urethral orifice is under skeletal muscle control, and somatic innervation, which is really good because this is going to be needing to pee and this is going to be actually peeing. You will have some actual control over that. Urinary bladder again has mucosa, submucosa, muscularis, and adventitia, and you should be relatively familiar with each of those at this point. And prove to ourselves that would be an adventitia. You can see the connective tissue outside of that urinary bladder. It is not generally considered a free-floating structure. Now the urinary bladder is lined with transitional epithelium. Who remembers transitional epithelium and wants to tell me about it? What's transitional about it?
I remember something about the bladder because, like, when it fills up, it'll push more up against the walls and it won't be, isn't it like columnar?
Not quite columnar. You're very much on the right track, though. So it's going to be transitional because it's going to transition in shape between a relaxed urinary bladder and distended full urinary bladder. So it is a stratified, non-keratinized epithelium, but the nature of the cells is not squamous. The nature of the layer of cells facing the lumen is going to have a very rounded appearance in a relaxed bladder, but it's going to become stretched out and flattened in a distended bladder. So yeah, you're absolutely on the right track. You got it. So that epithelium does have significance to the form and the function of the urinary bladder. Now note there's a difference in the length of the urethra between females and males. The females have just a short urethra. The external urethral orifice is anterior to the vagina, the vaginal orifice. And here you can see that internal urethral sphincter and external urethral sphincter, where they're two different muscle types. Or sorry, internal urethral sphincter is here, external is there, my bad. And that is a very short distance if bacteria wants to ascend into the urinary bladder. Whereas for men, there is, as we know from reproductive lecture, the prostatic urethra, the membranous urethra, and the spongy urethra. And that is a much longer distance for bacteria to travel. So men, typically, genetically male people, are much, much less prone to UTIs, urinary tract infections. Okay, we did that. The male urethra has both urinary and reproductive functions, whereas the female urethra is exclusive to transporting urine. There's no reproductive function for the urethra in females. Micturition is urination or voiding, many names for the same thing, and it is controlled very much by the autonomic nervous system. So what happens is the urinary bladder detects stretch in the walls, and that's going to send a signal via a visceral sensory autonomic neuron, or visceral sensory neuron, to the spinal cord, and then let's see, we should have this here. Parasympathetic activity from pelvic nerves is going to cause detrusor contractions and the relaxation of the internal urethral sphincter. So it is the parasympathetic, supposedly, activity. We're going to clarify this in just a second. For your worksheet purposes, this is what you're looking for. Parasympathetic activity, for our purposes today, is going to cause increased micturition, whereas sympathetic activity would hypothetically prevent micturition. That is what you need for your worksheet. I am going to clarify. Remember, when we talk about the autonomic nervous system, the most recent evidence tells us that sympathetic outflow is entirely sympathetic in nature. We used to call it craniosacral division. It's probably just cranial. So both decreased and increased urine production, formation, and urination will be controlled exclusively via the sympathetic nervous system going forward. But the people you work with, the resources that you're going to see for a very long time, are going to tell you it's parasympathetic activity that leads to urination. So that is what you should learn for now. Is that clear enough? Okay. That's it. Any questions before I turn off the recording?